In this tutorial, I'll give you a brief introduction to BRISC, and I'll show you how to set up a simple one-room model with a single opening, a vent to the outside, and then we'll do a simulation using the BRISC software. With BRISC open in front of you, along the top you'll see the main menu. We'll use this to access different options within the program and to enter our input data. Also in the centre of the screen we have another form called the console, where we can enter some basic simulation settings. We can start and stop the simulation, and in this area, which we call the log, we receive some information and output from the program while the simulation is running. The first thing I'm going to do is to create a new model and give it a unique name by typing it in the base file name text box. I'll just call it simple room example. Now I'm going to save the new model using the File, Save Base Model option. It asks, would you like to copy this project to the default BRISC data folder? I'm going to choose yes. And then it gives me the full path to the project files. And you'll see that the files are stored in your personal documents area under the BRISC data folder, and then there's a folder for each project. You'll also see the folder path shown underneath the log window. The default BRISC data folder can be changed by the user, and further instructions about how to do that are given in the user manual. I'm now going to enter data for our room design using the room design menu item. This opens a screen for managing the different rooms in a model. For a new project, it includes a default room. So I'm going to edit that for this example. I now get some information where I can enter details about the room and what it's made from. You'll see that we need our room to be described in terms of a rectangular shape with the given length, width and height. I'll make my room 5 meters long, 3 meters wide. And you can see there's an entry for maximum and minimum height. This allows me to have a sloping ceiling if I want. In this case it's a flat ceiling, so I'll make it 3 meters for both the minimum and maximum height. The elevation entry gives the height of the floor above some reference level. Now this is needed if we have multiple rooms with floors at different levels relative to each other. For this simple example, we can leave it at 0 meters. The next two entries for the absolute X and the absolute Y coordinates allow you to position the room horizontally relative to each other. Again, we can leave those set at 0 for this simple one room example. And if we want, we could give our room a short description as well. On the right hand side, we can select materials to be used on the wall, ceiling and floor, and the thickness. We can have either 1 or 2 layers for each surface, being a surface material and a substrate material. For the wall material, I'm going to choose the pick surface material, and I'll select a plywood for the wall, and I'll also change the thickness of the plywood to 12 millimeter. I won't include the substrate in this case, and I'll leave the materials for the ceiling and the floor at the default value. So let's save that and close out the room selection form. Next, we want to specify any openings or vents from the room. So we go to the ventilation menu item and choose wall vents. Our model has one vent already included by default, So here I'll choose to edit that vent. The first thing to do here is to locate the vent in the right place. For a single room, you won't have any options. The vent has to connect our room 1 to the outside. The face option allows you to select which of the 4 walls the vent will be positioned in. This is only used for correctly displaying the vent if you're using the Smoke View program. It doesn't affect any calculations in B-risk. So I'm going to leave it at the default setting here. I can give the vent a description or a label, say window 1. We'll change the vent width to 1.5 meters and the height to 1 meter and the sill height to 1 meter above the floor. Now we do have the option to open or close a vent at a specified time by entering the desired time into the text boxes here. However, this will only work if the close time is greater than the open time. For our simple example, I'll leave both times set at 0, which means the vent will be open from the very start of our simulation. There are some more advanced options available for automatically opening vents when certain conditions have occurred, such as flashover, but we won't be using them in this example. For all the other settings, we'll leave them at their default values, and we'll save our vent properties and close out the vent selection form. Now let's go straight into our fire specification menu and choose Select Fire. Again, we have a default fire object already present. If we edit that, you'll now see a screen with a range of different properties and settings for this fire object. This is where we would enter the data for the heat release rate, and also where we change some of the chemistry settings. An important thing to appreciate about the fire object is its location within the room, and this is important because location affects which entrainment algorithm is used. So firstly, the elevation of the base of the fire above floor level. Here we have it at 0.3 meters. And secondly, the distance from the left edge of the item to the wall, and also the distance from the bottom edge of the item to the wall. If one of these is set to 0, then that means the item is in contact with the wall. If both of them are set to 0, then the item is in the corner of the room. And obviously, if neither of them are 0, then the item is away from the wall. So for this example, I'm not going to change any of these default values. What I'm going to do is to return to the previous screen and use the Power Law Design File option. So click on the settings. So here I have the choice of 2 types of Power Law Design File. The most common one on the left here is a T-squared file, but there's also a T-cubed file option as well. I'm going to choose the T-squared file. The default fire growth rate coefficient, the alpha value. This is for a fast fire growth rate, so I'm going to keep that. But obviously you could change that if you wanted to use a moderate, a slow, or some other growth rate value. The other parameter you need to enter here is a peak value for the heat release rate. When the heat release rate reaches this value, then it will stay constant from that time forward. I'm going to make that 10,000 kilowatts or 10 megawatt, and I'll close the screen. So far we've entered the room design data, the wall vent data, and now the design file. At this point we're ready to run the simulation, but first I just want to check one more setting on the console screen. It's the maximum simulation time, which I have set here at 600 seconds. I'll leave these other settings at their default values for this simple example. Of course, there are other menu items and input screens where you can change various other inputs and settings such as ambient conditions and so on. But I won't be covering those in this brief introduction tutorial. Now, before we run the simulation, let's take a quick look at a summary of our model inputs using the View Input menu item. Now, we can scroll through this screen to review or check our input, and you can also print it out if you wish. So I'll close that. So now we're ready to start the simulation, and we can do that by clicking on the Start Simulation button on the console screen. Do you want to run the simulation now? Yes, we do. During the simulation, some commentary or summary event information is printed within the log window, as you see here. But there are a few different ways to view your results. One option is to view graphical plots for a range of different output variables. We see these under the single run graphs, under the main menu. For example, I can choose layer temperatures, upper layer, and I can see the plot of the upper layer temperature versus time. Next, if you want to see printed output, we can return to the View menu item and we can select View Results. This screen gives you a summary of both the input and the results. To see the results, we scroll down past the input and you'll see output at each of the time intervals. By default, only a small selection of the output variables are shown. These can be changed using the Select Variables menu item. Here we can select the different variables that we want to see within the printed output. Another option is to export the results to an Excel spreadsheet, and we can do that using the File, Export Results to Microsoft Excel. But as you may have noticed, there's also a shortcut item here, Send Output to Excel File. Of course, you need to have Excel installed, but that's a convenient way to get your results. So that concludes this tutorial introducing you to the BRANZ software and walking you through setting up and running a simulation for a simple one-room example. It's recommended you become familiar with the BRISC user guide and technical manual to develop a better understanding of BRISC and its limitations.